through, this is a continuation of our 3-6 notes on solving sinusoidal equations, and we're going to continue with the example we started and look at how to solve that sinusoidal equation algebraically. So first of all, we have previously graphed and through the intersection points found the solution to where the sinusoid y plus 7.5 times the cosine of 2 pi over 13 times x minus 4 equaled 5, right? Our y equals 5. So we're going to solve that equation algebraically, remembering that whenever we solve an equation, our goal is to get our variable by itself, which in this case is x. So we're going to follow these steps, and I'm going to identify them as we go through. So first of all, starting with step number 1, right, we're going to substitute our desired value of y, which in this case was y equals 5. It will be different for different problems, into our sinusoidal equation for y. So I'm going to rewrite this equation, except that I'm going to rewrite 7.5 as a fraction. So the equation I'm solving is where 9 plus 7.5 is 15 halves times the cosine of 2 pi over 13 times x minus 4. And I want to find the x that will make that equal to 5. It's 2 pi. So we're going to follow our steps. I want to get the x by itself, so I'm going to get rid of everything that's on this left side of the equation, right, working from what is farthest away from my x into where it is. So the first thing we're going to do, our a, is that we are going to subtract the c. Our c is 9, so from both sides of this equation, I'm going to subtract 9. Subtracting 9 right, takes away this 9, it subtracts it out, and that leaves us 15 halves times the cosine of 2 pi over 13 times x minus 4, which equals 5 minus 9 is negative 4. All right, so we've done step A. Step B is to divide by the A. So my A is 15 halves, and I can divide by A, or I can multiply by the reciprocal. And I think because it's a fraction, that's going to be easier, so I'm going to take both sides of the equation, right? This is my B step. I'm going to take both sides of my equation, and I'm going to multiply by the reciprocal of 15 halves by 2 over 15. And I'm going to do that on the left side, and I'm going to do it on the right side. So that divides out that fraction, my 15s and my 2's, leaving me the cosine of 2 pi over 13 times x minus 4 equals, right, negative 4 over 1 times 2 over 15 is negative 8 over 15. So that's my B step. My next step is to eliminate the cosine by taking the arc cosine of each side. So I'm going to come in here and I'm going to take the arc cosine of what I had, which is the cosine of 2 pi over 13 times x minus 4, right? And that equals what I do to the left side, I have to do to the right side. So we're going to take the arc cosine of what we have on the left, which is negative 8 over 15. So we've taken the arc cosine of the left side and of the right side. And that was my step C. So that was my step C. Because what inverses do, functions undo, right? What the cosine does, the arc cosine undoes, and they are going to undo each other. And that leaves me with just my 2 pi over 13 times my x minus 4. And And that equals the arc cosine of negative 8 over 15. My step D is to substitute that arc cosine with its definition. So my arc cosine of negative 8 over 15 by definition is plus or minus the inverse cosine of negative 8 over 15 plus, we're in radians here, so we will add 2 pi n. All right, we're trying to get that x by itself. We're making progress. So now we're ready for step E, which is to divide by the b. Our b value is this fraction, so to do step E, like we did before, instead of dividing by a fraction, we're going to multiply by its reciprocal. So we're going to multiply by 13 over 2 pi on both sides. On the left side, that's going to divide out both those fractions, leaving me nothing but x minus 4. Love that. Trying to get this x by itself, we're getting close. Now on the right side is the hardest thing we're going to do. We want to take, right, this expression, and we want to multiply the whole thing by this fraction, 13 over 2 pi. When we multiply things that are added and subtracted, we distribute over any addition or subtraction sign, which means we're going to take this 13 over 2 pi, and we're going to take it over the plus and minus, and then we're going to take it over this plus sign. So what I end up with is I have my plus and minus first, then I have my 13 over 2 pi times my inverse cosine of negative 8 over 15 plus, remember we distributed this 13 over 2 pi, so I have my 13 over 2 pi again multiplied by my 2 pi n. And nice things happen there, right? Both the 2 and the pi divide out, right? Leaving me just 13n. So I now have x minus 4 equals plus or minus 13 over 2 pi. Okay, at this point I'm going to put parentheses around the 2 pi because I'm dividing my 13 by both the 2 and the pi. It's a group. That's going to become important. That is multiplied by the inverse cosine of negative 8 over 15, and then we're going to add 13n. Almost there. My next step, step F, is to add the d, so I'm going to add 4 to both sides of this equation. Right? Adding 4 to the negative 4 divides that out, and that leaves me with x alone equals. Now, remember that addition is commutative. So if I'm going to add 4, I can add it anywhere in this expression. I'm going to take this 4 and I'm going to put it in front of the plus or minus. So that gives me 4 plus or minus 13 over, right, both 2 and pi times my inverse cosine of negative 8 over 15. And to that we add 13n. This expression actually gives me 2 different answers for x. I'm going to break that up. So I have x equals 4 plus 13, 4 plus 13 over 2 pi times the inverse cosine of negative 8 over 15 plus 13n, or I have x equals 4 minus 13 over 2 pi times the inverse cosine of negative 8 over 15 plus 13n. At this point, we can pick up our calculator and we can evaluate what doesn't have the n in it. So if in your calculator you put in 4 plus 13 divided by make sure the 2 pi goes inside parentheses, or you will only divide by the 2, not the pi. Then multiply that by the inverse cosine of negative 8 over 15. And when you do that, you will get 8.414. That is one of our solutions for x, and if we add any number of 13s, we would get all of them, right? Or, for our other set of solutions, we're going to take 4 minus 13 over 2 pi times the inverse cosine of negative 8 over 15. Right? Put that in your calculator, and that's going to give us negative 0.4, negative 0.414 plus 13n. And I have, right, these are all my solutions. Right? It represents an infinite number of solutions because I can take n to any integer. If I need any particular solutions, then I could add 13. So I could take 8.414 and I could add 13 to it. And that would give me 21.414. I could take 21.414, add 13 to that, and that would give me 34.414. Or, with my negative 0.414, I could add 13, and that would give me 12.586. Or I could add, right, I could take my 12.586 and I could add 13 to that, and that would give me my next solution. So for any sinusoid you're going to solve, right, you can do this. There are a lot of steps, but have your notes out. Make sure you're following each step, check each other, and I think you're going to do a great job. So that's it for us. Hope you've had a great weekend, and I will see